Hello students, in the last lecture we have seen the basic nature of amines. The basicity of amines that depends upon lower pair of electrons. Why amines are basic in nature? In amines there is a nitrogen atom is present, and that nitrogen atom has such lone pair of electron or unused pair of electron, and they can donate that lone pair of electron, this lone pair of electron, to proton or any electron deficient atom and forms a bond, and that property to donate the lone pair of electron to electron deficient species, that property according to Levy's acid-base concept, amines are basic in nature. If amines are basic in nature, then they must react with the acids, and in the last period we have taken the reaction of that amines with acids like H2SO4 or electron deficient species like BF3. Now today we are going to study order of basicity of amines. Now order of basicity of amines means ammonia, primary amines, secondary amines and tertiary amines. Out of these, which is more basic? Whether primary amine is more basic or secondary is more basic or tertiary is more basic or ammonia is more basic in nature. That is order of basicity. Today we have to see here. We are going to see here order of basicity. That order of basicity of amines depends upon different factors, and one of the important factors is influence of positive inductive effect. Influence of positive inductive effect. Now I have drawn here structure of this ammonia. It is the structure of ammonia, NH3. This nitrogen atom contains lone pair of electron. It is a RNH2. It is a structure of 1 degree amine, means primary amine. Here R2NH. It is the structure of secondary amine, and here R3N. It is the structure of tertiary amine. All these structures, they contain lone pair of electron on the nitrogen atom. Now order basicity depends upon that. When this nitrogen atom it donates the pair of electron to electron deficient species or to the proton, then after that this nitrogen atom it carries positive charge after donation of electron. After giving electron it carries positive charge, and the structure in which that positive charge is more stabilized, that structure is more basic in nature. Now we will see here. Now here, suppose this NH3 molecule, it contains lone pair of electron. It donates this lone pair of electron to this H plus, or it reacts with water in aqueous medium, and it is a reversible reaction, and it gives NH4 plus OH minus. This conjugate acid, it is a base, it is a conjugated acid. Now here, this lone pair of electron from this nitrogen atom it donates the lone pair of electron to the hydrogen atom of this water molecule. Here the bond between this H and OH, it is proton H plus. Now it is NH4 plus. It is get converted into NH4 plus. Now this positive charge which is present here on this NH4, if it is more stabilized, then it is more basic. Similarly, primary amines also reacts with water molecules RNH2 and gives RNH3 plus. Secondary amines also R2NH2 and here R3NH, like that. Now we will see here. Suppose this nitrogen atom carries positive charge. Here in this ammonia, this nitrogen atom is attached to 3 hydrogen atoms. These hydrogen atoms, they are not electron donating groups. Here now we will see here in this structure of primary amine, there is one alkyl group R, and it is this alkyl group, it is a electron donating group. Therefore, when this nitrogen gives or donates this pair of electron to the proton, then it carries positive charge. Then this nitrogen becomes electron deficient, and at that time, this electron, it gives or it donates the pair of electron. It donates it is electron donating group. Therefore, it shifts the shared pair of electron towards this nitrogen atom, and the intensity of that positive charge on that nitrogen atom decreases. It becomes stable than that of ammonia. There is no any electron donating group is present in this ammonia, but here one electron donating group is present. Therefore, this nitrogen atom, after donating that lone pair of electron, it becomes stable in comparison to that of ammonia. But here in secondary amines, this nitrogen can donate this lone pair of electron, and it becomes more stable than that of primary amine, because this secondary amine, it is attached, this secondary amine, this nitrogen atom is attached to two electron donating alkyl groups. The property of these alkyl groups is that they are electron donating group. They have the capacity to donate the pair of electron. When this nitrogen donates the pair of electron to the proton or electron deficient species, at that time it carries the positive charge and it becomes electron deficient, and to become stable, it accepts the electron from these two alkyl groups and becomes stable. Therefore, stability, as the number of alkyl group increases, here one alkyl group, here two alkyl groups, two electron donating alkyl groups, as the number of electron donating alkyl group increases, stability also increases, and basic character or basicity also increases. Therefore, now we will go here for the third structure. It is the structure of tertiary amine. In this tertiary amine, here these three alkyl groups are present here. These three. Here now, these three alkyl groups, they donate the electrons to this nitrogen atom, and this nitrogen atom becomes more stable in comparison to that of secondary and tertiary amines. Hence, as the number of alkyl group increases, stability also increases. As the stability of that amine increases, basic character also increases. Therefore, from this influence of positive inductive effect, the order of basicity of amines is like this. Tertiary amines are more basic than that of secondary amines. Secondary amines are more basic than that of primary amines, and primary amines are more basic than that of ammonia. Here I have ammonia. Here is the order. It is a increasing order of basicity. Here ammonia is less basic than that of primary amine. Primary amine is less basic than that of secondary amine, and secondary amine is less basic than that of tertiary amines. Or we can write the same order. It is a increasing order. In the form of we can write, or we can write here decreasing order of basicity. Tertiary amines R3N is more basic than that of secondary amine, and secondary amine is more basic than that of primary amine RNH2, and it is more basic than that of ammonia. Here in inductive effect we have to remind one thing, that as the number of electron donating group attached to that nitrogen atom increases, basicity also increases. Therefore, from this inductive effect, we can say that tertiary amines are more basic than that of secondary amines, and secondary amines are more basic than that of primary amines, and primary amines are more basic than that of ammonia. But it is according to positivity, it is according to this these alkyl groups donate the pair of electrons to this nitrogen atom, electron deficient atom. Therefore, it is known as positive inductive effect. It donates the alkyl group or electron donating group donates the electrons to the electron deficient atom. Therefore, it is known as positive inductive effect. But the actual observed order of basicity is like this. It is according to inductive influence of the inductive effect. But actual observed order of basicity is like this. Observed order of basicity is like this. Here it is ammonia is okay, no problem. It is less basic than that of primary amines. Primary amines are less basic than that of secondary amines. Primary amines are less basic than that of secondary. But secondary amines are, see this symbol like this. Secondary amines here, it is less basic, it is more basic. But secondary amines are more basic than that of tertiary amines. What does this indicate? It indicates that why according to inductive effect, basicity of tertiary amines is more, but here more than that of secondary amines. But here secondary amines are more basic than that of tertiary amines. It is the actual observed order of the basicity. But why this happens? Why the basicity of these tertiary amines becomes less than that of secondary amine? That is to be explained on the basis of solvation effect. Now here, influence of solvation, or that is also known as solvation effect. Influence of solvation on the basicity. Now after that, influence of inductive effect. Now the second factor affecting the basicity of amines is that influence of solvation, or that is also known as solvation effect, or that effect is also known as hydration effect. Now when this ammonia or primary amine or secondary amine or that tertiary amine in aqueous medium, when they are added in water, in aqueous medium, here now ammonia, when this reacts with this water molecule in aqueous medium, NH3 H2, H2 means H bond OH. Now this nitrogen atom, it donates the lower of electron to this hydrogen atom. The bond between this H and OH breaks here, and formation of NH4 plus OH minus takes place. It is known as conjugate acid. It is conjugate acid. It is a base. NH4 plus. If now similarly this primary amine reacts with water and forms. It combines, this RNH2 combines with one of the proton. It combines with the proton of this water molecule and formation of RNH3 plus. That is conjugate acid. Here R2NH. It forms R2, it combines with one of the proton from that water molecule and forms R2NH2. Okay? Here now, tertiary amine combines with H2 and forms R3NH. Now these are the conjugate acids, NH4 plus, RNH3 plus, R2NH2 plus and R3NH. It contains 4 hydrogen atoms, it contains 3 hydrogen atoms, it contains 2 hydrogen atoms, and it contains, tertiary amine contains only 1 hydrogen atom. Now, here, which of these conjugate acids are more stabilized by that water molecule? On that basis, the basicity order of ammonia and primary amines is, that depends upon that stability of that conjugate acids. Now first of all we see here. Now this NH4 plus, I have drawn the structure of here N 3 hydrogen atoms and here the 4th hydrogen atom. Now here in aqueous medium, now this nitrogen atom, it is electron deficient. The positive charge present on this nitrogen, it indicates that it is a electron deficient. And now if it is more stabilized, then it is more basic. Now this electron deficient nitrogen atom here, these 3 hydrogen atoms, and it is the 4, there are 4 hydrogen atoms attached to this nitrogen atom. They donate this H2 molecule, this hydrogen atom donates this H2 molecule. It is a nucleophile, it is an electron rich species. It is this oxygen atom with electron. It contains 2 lone pair of electrons, and this water molecule donates the lone pair of electrons to this nitrogen atom through this hydrogen atom. There is a weak bond formation takes place between the hydrogen of this NH and oxygen atom of this water molecule, and in this way it transfers this pair of electrons to this nitrogen atom through this hydrogen atom, and such type of the weak bond formation takes place, and these weak bonds are known as hydrogen bonds or hydrogen bonding. Here now this nitrogen atom it is more stabilized because it contains 4 hydrogen atoms, and these 4 water molecules, one here is second molecule, here is third water molecule, and these 4 water molecules donates pair of electrons to this, donates the pair of electrons to this nitrogen atom, and it stabilizes the nitrogen atom. Now here we will go for the primary amines now. RNH2 plus H2. Again this H2 means H2, here the bond between H and OH base here. This RNH2 nitrogen, it is a electron rich, it donates the pair of electron to this hydrogen atom, formation of RNH3 takes place here. RNH3 plus OH minus. It is a primary amine, it is a base, and here RNH3, that is known as conjugate acid. Now here, if this conjugate acid is more stable, then basicity is more, and that basicity depends upon number of water molecules attached to that molecule. Here in this ammonia molecule there are 4 water molecules attached to this nitrogen atom, because there are 4 hydrogen atoms to this attached to that nitrogen atom. Here now RNH3, here 3 hydrogen atoms. Now in this molecule, these 3 hydrogen atoms combines with 3 water molecules like this H2O, 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 and there is a weak bond formation, that is hydrogen bonding. And these 3 water molecules stabilizes this nitrogen atom, which is electron deficient, by donating the pair of electrons to this nitrogen atom through this hydrogen, that is through this NH bond, and there is a weak bond formation takes place between this hydrogen and oxygen, that is known as again hydrogen bonding. Here it means that here these 3 water molecules, they stabilize this nitrogen atom of the primary amine. Now we will move for here secondary amines. R2NH plus H2O, it gives R2NH2. Here again here HOH, here the bond between H and OH breaks here. This NH, it donates the lone pair of electrons to hydrogen, it is equal to R2NH2 plus OH. Here R2N, and now here this nitrogen will be attached to only 2 hydrogen atoms. Here in ammonia 4 hydrogen atoms. Nitrogen atom attached to 4 hydrogen atoms. In primary amine it is attached to 3 hydrogen atoms. Now here it is attached to only 2 hydrogen atoms. And these 2 hydrogen atoms here combines these 2 water molecules, donates the pair of electrons to this nitrogen atom through the hydrogen bonding, and there are only 2 hydrogen atoms, therefore it combines R2NH2, it combines with only 2 water molecules. And here in case of tertiary amines, R3N plus H2O, here again it donates the lone pair of electron to this hydrogen atom, it forms R3NH plus OH minus, R3NH, and in this molecule there is only 1 hydrogen atom, R3NH. And again it is stabilized by only 1 water molecule. As the number of water molecules are more, then that nitrogen atom, positively charged nitrogen atom, is more stable. कारण ज्या नायट्रोजन वरती पॉझिटिव्ह चार्ज आहे तो इलेक्ट्रॉन डिफिशियंट आहे, त्याला इलेक्ट्रॉनची गरज आहे. मग त्याला इलेक्ट्रॉन डोनेट करणारे किती ग्रुप झाले? 4 वॉटर. हे वॉटर मॉलिक्यूल हा इलेक्ट्रॉन, इट इज अ न्यूक्लियोफाइल, इट इज अ इलेक्ट्रॉन रिच स्पीसीज. हे H2 मॉलिक्यूल म्हणजे 4 वॉटर मॉलिक्यूल याला डोनेट करतायत 2 पेअर ऑफ इलेक्ट्रॉन्स, म्हणजे हा जास्त स्टेबल आहे. ॲज द स्टॅबिलिटी इज मोर इज द बेसिक कॅरेक्टर. हियर इन प्रायमरी अमाइन्स दिस नायट्रोजन atom is stabilized by 3 water molecules, therefore it is weak base than that of ammonia. Here secondary amine is stabilized by only 2 water molecules, and tertiary amine they are stabilized by only 1 water molecule. जितकी water molecules की जास्त संख्या तितकी stability है. Therefore from this solvation effect the order of basicity of amines is like this. Ammonia is more basic. Now it is reverse. to that of inductive effect, order of that inductive effect. Ammonia is more basic than that of primary amine. Primary amines are more basic than that of secondary amines, and secondary amines are more basic than that of tertiary amines. It is a decreasing order of basicity. And here we can write the same in this also. Tertiary amines are less basic than that of secondary amines. Secondary amines are less basic than that of primary amines, and primary amines are less basic than that of ammonia. It is a decreasing order. It is a ammonia is more basic. It is a decreasing order of basicity, and it is a increasing order of basicity. Less basic, more basic, more basic, more basic, like that. It means that इंडक्टिव्ह इफेक्ट मध्ये असलेली ऑर्डर तिथे काय होते की टर्शियरी अमाइन मोर बेसिक होते आणि अमोनिया लेस बेसिक. आणि इथे काय झालं, टर्शियरी अमाइन्सची ऍसिडिटी फार टर्शियरी अमाइन्स हा लेस बेसिक आहे आणि अमोनिया मोर बेसिक. एक्झॅक्ट रिव्हर्स झालं. बट ऑब्झर्व्ड ऑर्डर ऑफ बेसिसिटी इज लाईक इट. पण प्रत्यक्षात मात्र ऑर्डर अशी आहे, सेकंडरी अमाइन्स आर मोर बेसिक. ऑब्झर्व्ड दिस ऑर्डर अकॉर्डिंग टू सॉल्वेशन इफेक्ट. अगोदरची इंडक्टिव्ह इफेक्टची होती, परीक्षेमध्ये ते विचारलं जातं. Order of basicity according to inductive effect, order of basicity of amines according to solvation effect, and actual observed order of basicity is like this. Secondary amines are more basic than that of tertiary amines, and tertiary amines are more basic than that of primary amines, and primary amines are more basic than that of ammonia, and that is to be explained on the basis of combined influence of inductive effect and solvation effect. So the third point, that is combined influence of positive inductive effect and solvation effect. As for the positive inductive effect, here alkyl groups attached to the nitrogen atom, that increases the basic strength of amines. Therefore, according to that positive inductive effect, tertiary amines are more basic than that of secondary amines, and secondary amines are more basic than that of primary amines. Primary amines are more basic than that of ammonia. These are the NH4 plus. It is a conjugate acid. It is a R3NH. It is a conjugate acid of tertiary amine. R2NH. It is a conjugate acid of secondary amine. RNH. It is a conjugate acid of primary amine. And NH4 plus. It is a conjugate acid of ammonia. Means ammonia combines with water. It donates the proton to the proton of that water and forms NH4 plus. Similarly, primary and secondary and tertiary amines. Here now, positive inductive effect increases. Then tertiary amines are more basic than that of secondary amines. Secondary amines are more basic than that of primary amines, and primary amines are more basic than that of amines. If solvation effect, according to solvation effect, increases, then here increases like this. Then solvation effect, basicity increases like this. Means ammonia is more basic than that of primary amines. Primary amines are more basic than that of tertiary amines. Secondary amines and secondary amines are more basic than that of tertiary amines. Here basicity, according to that solvation effect, basicity increases from like this. And as for the positive inductive effect, basicity increases like this. Means here it is more basic, and here it is according to solvation effect. Solvation effect, it is ammonia is NH4 plus is more basic. But now here it is exact reverse order in positive inductive effect and solvation effect. According to solvation effect, ammonia is more basic and tertiary amine is less basic. And according to inductive effect, ammonia is least basic and tertiary amines are more basic. Now, but the observed order of basicity is observed, म्हणजे प्रत्यक्षात जी ऑर्डर आहे that is different one. ही अशी नाही आहे, according to solvation effect सारखी नाही आहे, inductive effect सारखी नाही आहे. But both these factors, solvation effect and inductive effect, both positive inductive effect, both factors are balanced in secondary amines. सेकंडरी अमाइन्स मध्ये दोन्ही फॅक्टर्स बॅलन्स्ड आहेत. देअरफॉर हेन्स ऑब्झर्व्ड ऑर्डर ऑफ बेसिसिटी ऑफ अमाइन्स इज लाईक दिस. Secondary amines are more basic than that of tertiary amines, and tertiary amines are more basic than that of primary amines, and primary amines are more basic than that of ammonia. Exactly, it is a observed order of basicity of amines. परीक्षेमध्ये नीट मध्ये असेल, बोर्ड एक्झाममध्ये MCQ येऊ शकतो, नीट एक्झाममध्ये असेल, जेई मध्ये असेल, CET मध्ये असेल, बऱ्याच या सगळ्या परीक्षेमध्ये या बेसिसिटीवरती MCQ बऱ्याच वेळेस असतो. तिथे तुम्हाला काय प्रश्न विचारला हे महत्वाचं आहे की ऑर्डर ऑफ बेसिसिटी अकॉर्डिंग टू इंडक्टिव्ह इफेक्ट जर म्हणलं तर इंडक्टिव्ह इफेक्टच्या ऑर्डरनुसार तुम्हाला अरेंज करावं लागेल. डिक्रीजिंग ऑर्डर, इन्क्रीजिंग ऑर्डर, वाट मिळेल. सॉल्वेशन इफेक्टनुसार विचारला असेल तर सॉल्वेशन इफेक्टची ऑर्डर सांगावी लागेल. आणि जर ऑब्झर्व्ड ऑर्डर ऑफ बेसिसिटी ऑफ अमाइन्स जर विचारला असेल तर तुम्हाला या ऑर्डरनुसार तिथं द्यावं लागेल. विथ दिस वी हॅव कम्प्लिटेड द factors, different factors affecting the basicity of amines. Today we stop here. Thank you.